Good day, students. Today we will going to expand our learnings about probability. And for today's lesson, we will going to define the difference between theoretical probability versus experimental probability. So are you ready? Now let's begin. But before anything else, let me read to you our objective for today. Today, I will be able to compare the theoretical and experimental probability by creating an experiment. But before anything else, let us have first our vocabulary. First, let us identify what is theoretical probability and what is an experimental probability. When we say theoretical probability, it is what we expect to happen based on math. It means to say that if I'm going to flip a coin, I have 50% chance of getting heads and 50% chance of getting the tail. So that is what we call theoretical probability. That is your assumption, or that is based on what we read in our book. That is the theory. That when I flip the coin, I get 50 chance of getting the head and 50 chance of getting the tail. But of course, if we were going to do a series of experiments, sometimes it does not happen. Sometimes if I flip the coin 10 times, there is chances wherein I get only 2 heads and 6 tail. And that is what we call experimental probability. When we say experimental probability, it is what actually happens when we test the experiment. Wherein, if I'm going to toss the coin 10 times, there are chances that I will get 3 heads and 7 tails, or 6 heads and 4 tails. That is based on our experiment. Okay, so again, when we say theoretical probability, that is the probability, or that is what we can see in our book. Like for example, for tossing the coin, there are chances, or there is a 50% chance of getting the heads and 50% chance of getting tail. But when we say experimental probability, that is actually what happens when we do, or when we test the activity or the experiment. Okay? So that is the difference between theoretical and experimental probability. Now, let's have a review. When we say tossing a coin, and when we say probability, this is the formula that we use. We have probability of an event. We have is equal to the number of ways it can happen and the number of total outcomes. This one is the same with our theoretical probability. Okay, so theoretical probability is equal to the number of ways it can happen and the number of total outcomes. Like for example, when we are tossing the coin, there is 1 chance of getting the head, probability of getting the head, out of 2 total outcomes. So what is the total outcome? 1 head and 1 tail. So the probability of getting head is 1 out of 2, or shall we say this is equal to 50%. And same with tail. What's the probability of getting the tail? How many ways that it could happen? There is 1 way, and the total outcome is, of course, there are 2 possible outcomes, tail and head. So the probability of getting tail is the same, and that is 50%. So that is what we call theoretical probability, that is based on our theory. Somehow, when we do our experimental probability of an event, it is equal to the frequency of an event over or divide the total number of trials. Like for example, we have 10 trials. Okay, so I toss the coin 10 times. Okay, and the frequency of an event I get, for the probability of head, I toss the coin 10 times. That is the total number of trial. And I get 3 heads. So it means to say the probability of getting the heads is 30%. And based on my experiment, when I toss the coin 10 times, the probability of getting the tail is 7. 7 over 10, or that is 70%. So do you know already what is the difference of our experimental probability and theoretical probability? Again, when we say experimental probability, this one is based on our experiment. But when we say theoretical probability, this is what we can see based on the book, based on math. Now, let us have an activity, or let us test whether we can have, or whether the theoretical probability can be the same with our experimental probability, or there is chances wherein we can get 50% of head and 50% of getting tail based on our experiment. So we already know that the theoretical probability of landing on heads and tails. So let us test it. We will flip the coin 10 times, keeping track of the outcomes of each trial. Then we will fill it in the relative frequency chart to help figure out our experimental probability. Then after we do the 10 times, we will going to do 50 times. After 50 times, then we will do 10 times, 10 or 100 times tossing our coin. Okay, so let's start. Based on our outcome, I toss the coin 10 times and I get, for the head, I get 2 heads. And for the tail, I get 8. For a total of 10 trials. So for this one, the relative frequency is 2. I get 2 heads out of 10 trials. So that is 2 over 10, or this is equal to 20%. And for our tail, I got 8 tails out of 10 trials. So for this one, I got a total of 80%. And if we were going to base this one in our theoretical probability, wherein the probability of getting the head is 1 over 2, or 50%, and the probability of getting a tail is also the same as 1 over 2, or 50%. Based on our experiment, I think it's quite different. So, based on my 10 trials, I didn't get 50% of heads. I didn't get 50% of getting a tail. But instead, I get 2 out of 10, which is 20%, and 8 over 10, which is 80%. Now this time, let us keep on tossing our coin. This time, we will going to try 50 times. Let's start. So after our experiment, after I tossed the coin 50 times, I got 23 heads and I got 27 tails. In this, I got a relative frequency of 23 out of 50 trials. And for this one, when we divide 23 over 50, this will result to 46%. And for that tail, this one is 27 over 50. And when we divide 27 divided by 50, we got 0.54, or this one is 54%. Based on what we can see here in our experiment, it is not 50%, but as what you can see, 46% and 54%, it is close enough to 50% heads and 50% tail in our theoretical probability. But of course, it's not exactly 50%, but close enough. Okay, so that is 50 times I toss the coin. How about we were going to continue tossing the coin for 100 times, and let's see what happened. This time, the result is, I didn't expect that this will happen, but after I toss the coin 100 times, I get 50 heads and 50 tails. So this is unexpected, but actually, as we do the number of times, as we have more number of times tossing the coin, the result is the same to our theoretical probability. Wherein, for our relative frequency, I got 50%, 50 over 100, and that is 50%. And 50 over 100 for the tail, and that is also 50%. What will be our conclusion for this one? For our conclusion, over a large number of trials, the experimental probability become closer to theoretical probability. Okay, so take or remember, put in our mind that, of course, this is just an experiment. Maybe after we do the 100 times, we cannot have the 50%, but if we were going to do 100 times or thousand times or million times, our experiment will be closer to theoretical probability. Okay, so that is the difference between theoretical and experimental probability. Again, when we say theoretical probability, that is based on math. And when we say experimental probability, that probability is based on the activity or based on our experiment. And what is our key thought for this day? For a large number of trials, the experimental probability become closer to theoretical probability.